Remind you what we have covered till now in this chapter. We were discussing carbonyl compounds, their naming. Then we have gone through synthesis of aldehydes, synthesis of ketones, aromatic ketones. We have given the mechanism of Resin-Mandis reduction. Then we were discussing about Friedel-Crafts acylation reaction and its mechanism. If you remember in last lecture, we were discussing about the mechanism of Clemson's reduction. So today I am going to discuss the mechanism of the last reaction related to aldehydes and ketones, that is Wolff-Kishner reduction. Wolff-Kishner reduction, basically this mechanism was proposed by Wolff. His name is Ludwig Wolff, and Kishner, Nicole Kishner. The difference between Clemson's reduction and Wolff-Kishner reduction is, in Clemson's reduction, the reaction is taking place under acidic medium. So we are using their concentrated hydrochloric acid, HCl. But here, the product is same. We are going to get alkanes also, hydrocarbons also. We have to convert carbonyl group of aldehydes and ketones into methylene group, CH2 group. But here we are doing this reaction under basic conditions, under basic medium. The general reaction is, suppose here we are taking, suppose this is carbonyl group, in the presence of hydrazine, NH2, NH2, number under basic conditions, and the solvent used here is ethylene glycol. Ethylene glycol. It's acting as a solvent, nothing else. So we are converting this carbonyl group into methylene group. So the condition is here, this C double bond O, we are converting into CH2 group. This is carbonyl, we are getting it methylene group. Now this reaction is for both aldehydes and ketones. So for example, if I take, this is R, this is H, in presence of NH2, NH2, KOH, instead of ethylene I will write EG, short. Ethylene, it will give us, now we can say RCH3. This is alkane. Similarly, if I will take ketone now, in presence of same conditions, so it will give us so you can write it also like this. This is also alkane. The purpose of the reaction is to reduce carbonyl group, C double bond O group of aldehydes and ketones. It is specifically for aldehydes and ketones to reduce the carbonyl group into alkane, any methylene group, CH2 group. The mechanism is not difficult, but you have to be very careful because there are 3-4 steps in the mechanism. So it will be the OH minus will be the base. So let me give you the stepwise mechanism of the reaction. So be very careful while I am writing the mechanism of the reaction. So I will give you some examples also. Then we will start. I will give you some practice problems so that you will be confident about the mechanism of the stepwise mechanism. So I will take a general reaction. For example, so I will take ketone in presence of NH2, NH2, KOH, ethylene glycol, we have to get alkene. So this is a general reaction. Let me give you stepwise mechanism. The step number 1, what is going to happen? This carbonyl group, it will be attacked by the NH2 NH2. You know what is this? It is hydrazine. So this is hydrazine. This because of this hydrazine, there will be this O and there is release of water. So when there is release of water, C double bond, then they will be bonding with N. So here we have double bond and there is N and NH2. So I can write this NH2 like this also. H. There is some purpose why I am writing it like this. After this, the base will come to attack on this hydrogen. OH minus from KOH. It will give K positive plus OH. This base is strong. It will try to attack on this hydrogen. So when it will attack on hydrogen, it will go like this. This H positive will come out. This O will attack on this. There is release of water. Now if you see by this step, then there will be negative charge on nitrogen. So what will be the resulting molecule? Double bond. We have N. We have NH. Now you know we have here electron pair, here is also electron pair, but still there is again negative charge by removing this hydrogen. Now here in this step it will show some resonance. This step will show some resonance because of this. So what is going to happen? It will come here and there will be negative charge on carbon. The result will be N, carbon single bond N, and there is hydrogen. Double bond will come here. Here will be negative charge on this carbon. So this carbon is going to get negative charge and double bond will come here. This is first step. This is resonance molecule. After this, now step number 2. In step number 2, we will bring this molecule here again. Okay. Now we have here negative charge. If you see in our mechanism, in our reaction mixture, we have already water there. So water is going to play a part here. It will go minus, it will positive. This negative charge, it will pull up this H positive, and it will push OH minus. OH minus will be pushed off. So what will be the result? The molecule, it will be like this. We have N double bond N, and we have attached with it. This is double bond. And if you see, this carbon has already pulled H positive. So H positive will come here. Now in this step, after this, again OH minus from this base, it is going to attack on. It is going to attack on this hydrogen. It will not attack this hydrogen because the electronegativity difference between carbon and hydrogen is very less. So bond strength is more. While as electronegativity difference between nitrogen and hydrogen is big difference in electronegativity. So this bond will be easy for OH to pull up, to abstract from this nitrogen. So if it is going to happen, what will happen here? Let me show you. It will bring negative charge on nitrogen. So here will be, so what will release? H2O. N double bond N, and there will be negative charge. Okay, and here is already oxygen. This is carbanion, this negative charge of the molecule. Now we have to focus in the mechanism how to remove this NH2 from this molecule, so that once it is bubbled out from this molecule, we have chances of inserting another hydrogen molecule here, so we will get the result which we are looking for. So let me show you. I hope in the first step we will get this molecule. This is called the hydrazone. So keep in mind, this is hydrazine. After doing reaction with carbonyl compound, it will become hydrazone. Then there is a resonance formation of the molecule. This is the first step. In the second step, we will taking this molecule again, doing reaction with the water which is already in the reaction mixture. We are going to get this molecule. After this, base will come also to attack on this hydrogen. We are going to get this molecule. Now in step number 3, let me clean step number 1. In step number 3, we have here N, double bond N, there is charge also, negative. So here we have hydrogen. We are looking to make sure that there is another hydrogen so that we can pull off this nitrogen molecule. So after heating this, it will show some resonance. It will go like this, and it will force this bond to break down. So there is release of N2, N triple bond N, means N2 gas will be released. It will be bubbled off from the reaction mixture, and we are getting negative charge on this carbon. This is hydrogen here. Now we don't have this bond because already we have broken this bond. So but we have negative charge on this carbon. So after this, again water will come to take part in this mechanism. It is going to be negative, it is going to be positive, and this carbocation, this carbanion, it will attack, it will abstract the hydrogen from this water molecule and pulled and push OH minus out. So what will be the result? This will be the final molecule, final compound. We have H here, here will be another H, because this carbon is attacking on this, so we can write like this also, R CH2. This is alkene. This is, so if you see in my first before showing this mechanism, I focus on, we have to figure out how to convert this, how to make sure that we can convert this carbonyl group into methylene group. This is the stepwise mechanism. First mechanism, there is formation of hydrazone, and the second step will show some resonance. In the second step, water will come and attack on this molecule, and it will result in the formation of this molecule. This molecule, if you take in the third step, after heating, it will bubble out nitrogen gas N2, and it will result in the formation of this molecule. This molecule will again attack on water, and it will pulled up the H positive and push OH minus. So there will be result of this molecule. This is the alkene. Now it was general mechanism. I will give some example of aldehyde. What is the name? Benzaldehyde. Okay. In presence of NH2, base KOH, ethylene glycol as a solvent. What will be the result? So we will introduce two hydrogens here. This will be 1-methyl benzene. So we are trying to convert this carbonyl group into methylene group. Now let us start stepwise mechanism. So if I start stepwise mechanism, let me take first step number 1, this benzaldehyde. Plus hydrazine so this O and H2 will be released as water molecule. The result will be there will be double bond with N and H2. Okay. Now after this step there is attack of this base KOH. You know it will give K positive plus OH minus. This OH minus will attack on this hydrogen. So for your convenience, let me write it in different way so that it will be easy for you to understand. Okay. This bond is going to break like this. There will be negative charge on this. This H positive will come out and this OH will attack on this. There is release of water. Release of water. The molecule will get this shape. We have here triple bond. We have here N and N. H. You know there is negative charge. This is negative charge. Now this molecule will show resonance. When it will show resonance, this bond will come here, double bond. This bond will break, so there will be negative charge on this carbon. Okay. There will be single bond with nitrogen and double bond will be here and it is already attracted with this hydrogen. So this carbon will be having negative charge. This carbanion I will use in step number 2. In step number 2 I will take this carbanion. Okay. So there is hydrogen also. Yeah, there is negative charge. So then the water which is already available in our reaction mixture, it will go like this, it will make H positive. This minus charge, it will attack on this hydrogen and push back OH minus. OH minus. So what will be the product here? We have here this bond, there will be nitrogen. Okay. So when it will attack on this, there is formation of this molecule. So this carbanion, it will attack on this hydrogen of water molecule and push out OH minus. There is formation of this molecule, and this molecule will be further attacked by the base OH minus. That will attack on this carbon. Now we have here hydrogen because this hydrogen came here. Now this OH will attack on this hydrogen instead of this hydrogen. I told you, I repeat again, because the electronegativity difference between carbon and hydrogen is very less, so it will directly attack on this carbon, on this hydrogen So this hydrogen will be like this, it will come out H positive. This base, it will attack on this, there is release of water. Okay. So there is formation, this N, double bond N, there is negative charge, and here is also another hydrogen. There is also another already hydrogen here, this hydrogen, and N, double bond N, because of this there will be the third step will be negative charge, and we have also here another hydrogen. So in the third step, if we will give heat to this molecule, it will be easy to release N2 gas as N triple bond, and it will be bubbled out. Okay, so because of this, there will be minus charge on this carbon. There is hydrogen and there is negative charge on this carbon. This carbanium will be further attacked by water. This will be positive. What will be the result? Result will be this carbanium, this minus charge, it will attack on this hydrogen, and this OH will be pushed out. So we will get the final product. We will get the final product. There will come, this hydrogen will come here. So what is this molecule? 1-methyl benzene. This is the mechanism. Now let me give you some practice exercises. Practice at home. So give the stepwise mechanism. What is this molecule? This is ketone. This is ketone. Okay. KOH and EG is ethylene glycol. Give the mechanism. Ethylene glycol. You have a give stepwise mechanism of this reaction. This one, this one, this one. There are 3 steps. In the first step there is hydrogen formation, and there is, after this molecule there will be a resonance. In the second molecule there is, in the second step there is a charge on nitrogen. In the third step you can again attack, you can give heat. After heating again attack with the water molecule. It will help us to give hydrogen, and finally we will get the alkene molecule. We will be successful in converting carbonyl group into methylene group. So this is the end of the Wolff-Kishner reduction, and we have now completed Grimson's reduction, Wolff-Kishner reduction. And my request to all of you, stay at home, stay blessed, and take care.